Hello, everyone. My name is Brian Farrell, and I'm here with another video. So I am a PhD student studying computer science, and in this video, I wanted to share just a review of literature with all of you that ended up being like pretty instrumental to one of my research papers that I did a couple of years ago. And so the aim of this kind of literature review was to bring just different perspectives on how well BERT performs on tax classification tasks, which is what I ended up studying, and how well it kind of does like in different domains, and digging into like how people have improved BERT with some creative methods. And just FYI and advice, a literature review is a really awesome thing to do and skill to get good at. Um, To be honest, I hate reading, but for some reason, for literature, I love reading it. It's like a smarter form of Googling, right? Like everybody Googles stuff. Everybody is curious about something. So if you ever like just had like a random question that you wanted to Google, right? That's a completely normal thing to do nowadays. And so literature reviews are kind of similar, where you have a research question or something that you're interested in and digging really deep. And there are people out there who have done like similar projects, similar research, and you get to see like what analysis they did, what results they had, like what are different constraints that they had with their research. So it's like a cool nerdy way of like a smarter form of googling, as I like to say, because I don't just like read books just for the sake of reading, but for some reason I really like this stuff, and maybe that's why I like research and getting my PhD. um, but for my own text classification like research problem, I wanted to see how BERT kind of stacked up against various traditional like deep learning methods. Therefore, this kind of review was it was good for me to get started on how well BERT does and maybe some of like the weaknesses that it has. So for those who don't know like what BERT is, BERT stands for bidirectional encoder representations from transformers. And so this is a transformer-based model, and it has 12 attention heads and 110 million total parameters. You don't have to necessarily know what any of that means, but it's a very large language model that allows for it to understand context and just general language, like how language is written. And so the way attention works is it learns contextual meanings of words and how each word is being used in a sequence, right? So the sentence, you know, I love Pirates of the Caribbean. It is an amazing movie. Bert would understand that is referring to the Pirates of the Caribbean movie, based on the context. So this model was pre-trained on enormous data sets, things like book corpus and Wikipedia, and it's just learning and getting a grasp of how language works and how it can be written. And then the language model is then fine-tuned or transferred to whatever task you want it to do, which in our case is text classification. And this is a process that is called transfer learning. So this kind of evaluation that I have in this video revolving around like literature is going to kind of discuss how BERT um, does like at different text classification tasks, how it stacks up, how like the performances, and maybe slightly how can we make it better and what are some of the weaknesses, right? So the video can be broken down into two sections. The first is comparing BERT to classical machine learning methods and other neural networks. And then the second part will be exposing BERT's vulnerabilities and improving like how it does using adversarial attacks, which I can go into a little bit later. Um, and improving like how it does in specific domains and examining like the layers within BERT. And I have this GitHub page that has like this literature. So I'm going to be going through like each of these papers and just give like a simple, broad, general overview of what the authors did, some of their analyses, and whether or not BERT came out on top. At least for the first part. The next part is going to be going over adversarial papers, which is just like a way to try to make BERT trip up, essentially, and mess up. And then very, very briefly going into how you can improve it, and then what, other models that are out there that could be better, and more trained specifically for your, domain, right? So I have this page on my GitHub, and I can share the link in the description. There's going to be a literature review, which is, going to have like basically the same thing, just kind of a brief kind of overview, and then an annotated bibliography, which is even more brief, which is just listing out the topics, the papers, what the authors did, and whatnot. And you can check this out on the GitHub. So this is kind of the first kind of introduction to what I'm doing. And so, yeah, let's get started. So like I said, I was going to review kind of a little bit about some of these papers. I won't go too deep into the actual, I'm not going to read it to you guys, but I'm gonna give like a broad kind of explanation on what all happened and what the authors did. It's really good practice to do like a meta analysis on a topic, right? Like I'm only looking at a handful of papers, especially when I'm comparing like versus other methods. Like in reality, you want to at least find a paper that reviews hundreds of papers where you're comparing BERT to other methods, right? Like I only have 6 papers here. And yeah, like within these papers, they're running multiple experiments, which is a good thing, but you would want to have like triple the amount or 10 times the amount of papers just to add to the validity and accuracy to what you're saying, right? Because you don't want to be somewhat biased. Maybe these particular papers is such a small sample size, BERT just happens to be better on these, but maybe somebody could have found another 6 papers where BERT didn't do so well, right? So you wanna have like a bunch of them. But I still wanted to kind of like review because BERT is it's a widely used thing in natural language processing. Like BERT is going to be the main model that people compare things with because it's just the most popular. It was the first thing that came out in 2018, and it changed how we model language. It changed everything with using the attention, and even just the attention is all you need paper. Um, just changing the scope of how these models look at our data, our unstructured text, and kind of make sense of it. Now, the models don't tell us how it's making sense of things because they're a bit of a black box, meaning what goes in and what comes out, but you don't know the intuition behind these models, which is maybe another reason why you would want to use a less accurate model because you can actually explain like why it makes a decision. With these models, you can't. But it's still likely that BERT's going to play a big part in how we just model language, right? It's going to be the benchmark against even more powerful transformers that are out there. And there's just a ton of papers about BERT. If you take BERT and you switch it up a little bit and you train it on financial data and you call it FinBERT, you're going to compare that model to BERT. BERT's going to be a great baseline model for a very long time. It might not be the best one, but it's going to be the most popular one for a lot of different tasks. And so this kind of review is meant to show just different results from literature where authors attempt to use this language model and then fine tune it for their classification tasks on just different data sets. And these data sets might not be real world, they might be kind of easy ones like the IMDb data set. But it's still really cool to see like how BERT performs. And a lot of these papers, you will find that BERT can be superior, whether it's large data sets or small data sets, short text lengths, longer text lengths, or even data sets of just different languages. And I believe like, the author's intent with a lot of these comparisons is to see if BERT should be the default when it comes to NLP tasks, as opposed to some of these other traditional methods, and kind of examining like how BERT can dominate um, in comparison to traditional ways of handling NLP problems, right? And the perception of BERT is that you need a large training data and large amounts of computing power. And a lot of this research shows that that's just not the case. And even in my own research, um, I didn't have a ton of training data, and there's different things that you can do to kind of combat that, right? So you have this first paper, which is comparing BERT against traditional machine learning text classification tasks, right? So these authors, they ran 4 experiments on 4 different data sets using BERT and then several kind of well-known different machine learning models. So they called them well-known. A lot of them I've never actually heard of before. I don't think the authors actually go into why um, they choose some of these other models. Um, but I like how they kind of simply wrote their paper. It's very straight to the point. I like how it's organized. The first experiment is looking at the IMDb data set, and there's 50,000 examples, and they split their training and testing data like 50-50, and they do sentiment analysis. The second experiment is comparing BERT to something called H2O's AutoML. This is another kind of binary text classification task on a data set called the real not tweets. Let me try and find it so I'm not looking for. There we go. Yep, real not tweets. And this is kind of a cool data set. It contains tweets about real disasters and tweets that are not about real disasters. Basically using like metaphors, which is really kind of like interesting. It's an interesting experiment, interesting like kind of research to have. I've never really heard of a task that is like for that. But the third and the fourth experiment are a different language. So instead of using English, they use a Portuguese news data set. And there's 9 different classes. And then the fourth experiment, they use a Chinese hotel reviews data set, right? And so for these, they're comparing BERT to the AutoML model. They use different ways of just kind of splitting the data and the training and testing set. Um, a lot of these data sets have different, like just varying amounts of data. So, it was a good way to try out, different ways of splitting the data. And BERT came out on top on all 4 experiments. Um, I wouldn't say that like BERT had an enormous lead, and you can take a look at the results yourself. But in terms of accuracy, and accuracy is not really the perfect way to test out a model. But in terms of training time and effort, this is where kind of BERT came out on top. And um, they reference kind of parameter tuning and how many epochs were trained. And the authors basically admit that like BERT turned out to be far less complicated than implementing the traditional methods. And this is true because you don't have to do um, a feature selection with these huge black box model. You just download them and use them. In some ways, that's kind of scary, but in other ways, it saves you a lot of time. You don't have to have, um, you know, necessarily domain experts. I mean, you should to pick the correct data, and to pick a unbiased data set. But just in terms of like training BERT, um, it's a lot less stressful when it comes to like a lot of different parts of like the actual training. The only thing about this paper that's, missing in my opinion was just a breakdown of the data, and any sort of limitations of BERT that the authors kind of might have discovered. They don't really mention anything about, what learning rate they used or anything like that, which is, you should have that in there. Um, the next paper is BERT versus other machine learning methods for small data sets. And so the authors, Peter Usherwood and Stephen Smith, they kind of demonstrate in their paper that BERT can be just as amazing on data sets where there's only 100 to 1,000 examples per class, which is, that was kind of ideal for my own research because there was only a couple of hundred, even less than that for some of the outlier classes. And so they compare BERT versus ULM fit, um, on a variety of just classical methods, just the ones mentioned kind of before in the previous paper. Um, they do take the time to address like the lack of quantitative studies like on smaller data sets, which I really appreciate. They focus like their efforts on 5 data sets using sentiment-based classification tasks. They use Amazon reviews and Twitter reviews. And for the Amazon reviews, they have 3 data sets containing movie reviews, book reviews, and health and personal care product reviews. The other 2 data sets that are from Twitter are from a SEM eval 2017 task. And some of the ways of how they test for and the other models is they use Amazon trained classifiers on other Amazon data sets and Amazon trained classifiers on the Twitter data sets and vice versa. And this was kind of a really interesting paper. And I would suggest, reading this. Um, and it's, different multiple domains. And it's really, really like, it's really interesting how they did this. And you can see in the paper, I can pull it up. Um, in this table, that BERT outperforms the machine learning models as well as UML fit. And the overall results for each of the models are, not necessarily spectacular. And, maybe more data would be needed or the use of like cross validation if they had like the resources for it. But the authors still point out that there's less time spent on hyperparameter tuning when it comes to BERT, right? So simply just changing the epics or the learning rates, like that's all they did. Other models will have like a whole bunch of hyperparameters, and especially like traditional things like LSTMs or CNNs. Like if you're constructing like your own custom model, like all of those parameters go skyrocket um, exponentially in terms of the amount of possibilities that you could be trying out. And that's kind of how I felt in my own research, where there's millions and millions and millions of different numbers to try just to see what work. Not even just a learning rate or the amount of epics to use. And it's hard. And BERT really simplifies this process. So another paper, which is detecting Alzheimer's, um, titled "To BERT or Not to BERT: Comparing Speech and Language-Based Approaches for Alzheimer's Disease Detection." Um, and this was a really cool paper comparing BERT to feature-engineered machine learning models for detecting Alzheimer's disease in speech transcripts. And this is from the address data set. Um, and so basically, since humans find the features within machine learning models, this is something that is time consuming. And this is something that is error prone. Um, and you're requiring an expert to be part of the process and to have domain knowledge, which is why they want to test how BERT performs. Um, and this is just another challenge where the data set is quite small, consisting of I think it was 156 speech examples where they split the data 50-50 for either non Alzheimer's or it has Alzheimer's participants. And they are basically tasked with describing a picture and predicting whether this was somebody with Alzheimer's or not. Um, and they used cross validation strategy, but not for BERT because of memory constraints. And um, in the results from the training sets and the holdout sets, BERT outperforms all the models. Had they tried different amounts of folds or used BERT without cross validation, would the results have been different? You don't know. But basically, in conclusion, like the authors wish to kind of explore like different ways of combining representations from BERT with those kind of handcrafted features, which I think would be really cool to see if it kind of boosts the performance in any sort of way. Um, the next paper, which is BERT being used in other cultures. So this team of researchers use BERT for malicious online behavior detection. And this is, an interesting paper to view how BERT is being used in places just outside of America with different sets of values, different goals, different cultures, different ways of protecting people's social welfare. Um, and I won't show like the results from their classification because they just have an exhaustive list of models being compared to BERT. They used DistilBERT. Um, they used bidirectional LSTMs. They used attention models. Um, they used five-fold cross-validation. And the authors point out that DistilBERT, which is like a smaller, compact version of BERT for faster training speeds, and BERT do better on a number of just binary classification tasks that they had for each data set, predicting whether something was, malicious or not. So this task is very unique because, how do we draw the line between what is malicious versus what is sarcastic, right? Even if like we can differentiate between what is considered malicious, which I'm sure we can, what do we do with that kind of power when it comes to people's opinions? It also seems that having like the perfect data set for their task just does not exist. And that's a big thing with data science is data sets can contain biases. Data sets aren't perfect. You could have this really clean um, data set that has a lot of data. You could have multiple classes and it's balanced, but it could still be the wrong representation of your population. And the authors even point out um, unintended biases in their paper, and these biases occur from different ways that the data sets are retrieved. So sampling bias, and it leads to discriminating against people or groups differently. Maybe not in this study, but in a lot of studies, how you pull the data can discriminate against different groups in unfair ways. For example, just mentioning gender, religion, or sexual orientation apparently can just have higher malicious scores, even if the comment is not intended to be hateful. And the authors point that out. So nonetheless, it's kind of interesting to see like how different cultures use BERT and these language models. And, it still performed well in this quote unquote bad behavior detection and the different varying data sets that they have. So I would suggest, looking at it and kind of making an opinion of yourself. So there's another paper um, that I have where it's comparing different models for sentiment analysis or in drug reviews, right? And so um, these authors kind of present just different advanced like NLP models on sentiment analysis tests on drug reviews. The models that they used, for example, they used an LSTM, um, convolutional neural networks, SVM, and then just hybrid models. And they used BERT plus LSTM. And the data set that they got is taken from drugs.com, which comprises of drug reviews with their like score. I guess it's a score that reflects like a patient's degree of like satisfaction with the drug. Um, and they kind of do this paper in two ways, two different um, or this task in two ways. So they classify ratings based on a 10-point scale and then reduce the 10-point scale into a 3-point scale by combining the ratings into 3 levels of polarity. So negative, positive, and neutral. And this is smart because it gives you a more general, broad um, decisioning basis for your model, right? So in my research, I did it in a similar way where I had 6 classes and I reduced it down to 3 because it just gives a more broad, general kind of view of your data. And a lot of, if you spread yourself too thin, you can end up having um, too many classes in one class and not enough. So, for example, if you have 10 classes, you could have not enough in the 10th class. But if you combine classes 7, 8, 9, 10, it gives you more data for that class. Um, and so the models other than BERT that they use for their kind of word embeddings was trained on PubMed, PMC, and Wikipedia. And the other was trained on tweets about drugs. You can kind of come back to this paper to review to look at the results and just the different embedding styles that they use for the different data sets because they had a really large list. But they ran the BERT and LSTM model for 200 epochs, and they had a learning rate of 0.001. Um, I part of me wants to know why they steer away from the BERT author's recommendation of 3 to 5 epochs, and also why their learning rate is so large. Um, they could have just used another BERT that relates better to their domain as well, since it's drug reviews. So there's things like clinical BERT or bio BERT. Um, I think I would have liked to have seen BERT being used by itself without the LSTM. I don't think that they go into why they use the LSTM model attached, just to see if it's even necessary to do so. But overall, BERT still does really well. But it took a super long time to train because you have the LSTM tacked on to BERT and you're running it for 200 epochs. So very kind of just curious on why the authors kind of did that. Another paper that I looked at was BERT models applied to radiological classification. And so this is a medical domain kind of corpus combined with a BERT model on this multi-label text classification problem. The authors point out that the challenges when it comes to electronic health records is that they're very hard to read, they're very hard to classify, they're hard to do research on. They could be It's hard to access sources due to this data being unstructured and different privacy concerns. Um, and to help just automating this task, they wanted to use BERT and kind of comparing it. And this is a database in which where they had hand labeled their data set. Um, and they also had just multiple labels for a CT report. Um, and so you should go in and check out this paper. They compare just the regular BERT to BioBERT, and talk about the label counts and the frequencies. And the authors do a really good job at kind of breaking down the results and showing the accuracies per label. Um, I don't think that there was a significant difference between BERT and BioBERT. Um, but the study demonstrates once again like the power of transfer learning and BERT's robustness, but with a twist of including a combined medical and general domain kind of corpus as well. So the takeaway from this kind of first segment of papers is, um, condensing classes to fit a more general spectrum might be the best thing, and it might give you a more accurate model. Um, Also, the use of cross-validation shouldn't be something, ignored, especially for small data sets. And then BERT performs very well across multiple domains. So I would suggest just try things out, see what works. Keep experimenting. There's no guarantee that BERT or specific domain of BERT is best for your task, but try out different models and run your analysis. Okay, so now we can talk about different ways in terms of how to improve BERT. Sometimes BERT gets a lot of praise for what it can do and what it can achieve. Um, but here we explore different papers and tactics for exposing the weaknesses in BERT, viewing the layers within BERT and how BERT can be faster and more scalable by reducing the amount of parameters it has. Um, so you have these things called adversarial attacks. And these three papers, and you can look at these and kind of see what else is out there. Um, these papers go into attacking BERT. And at first I didn't understand why would somebody purposely, you know, want to make a model bad, right? And in this paper example, right, like they're changing sentences to cause prediction accuracy to go down. At first I didn't get why that was so important. And I realized that the reason behind these attacks is to expose weaknesses and to help understand what the model gets wrong with just a few simple changes in the text. And these simple changes would lead you to believe that BERT would still get the correct answer, but just a simple change in synonyms, or inserting words that are not or are still contextually, correct, but it changes the result. And here in this example, this picture that they have, this tool that they use called Text Fuller, um, it's changing words that are synonymous to each other, but BERT ends up getting it wrong. And so this Text Fuller algorithm is a great baseline for comparing different results, but um, the better ways of running adversarial attacks are through semantically similar words that best fit the overall context of the sentence. So, two examples of algorithms that leverage the power of BERT to expose BERT would be um, this paper, which is BERT-based adversarial examples, and then BERT attack. And this paper titled BERT attack, adversarial attack against BERT using BERT. Um, and creating adversarial examples is becoming very popular. And I think when testing the robustness of BERT, it doesn't get more robust than picking BERT apart limb from limb just to see where it messes up, on semantically similar sequences. And the authors have different examples and a Python framework that has like 15 or more, attack strategies, as well as like data augmentation techniques and model training. Um, but other than just like attacking BERT, there are other ways of improving BERT by examining underneath, BERT's hood. So there's a wide range of solutions to make BERT perform better. Um, for example, like, examining different data sets, examining learning rates for specific layers. How do we deal with longer sequences? And according to some of these authors, like different layers of BERT capture different types of information, different semantic and syntactic information, and they examine those layers to see what learning rates are best used for different layers. Um, and authors conclude that like the top layer is the most useful when it comes to text classification. And then further pre-training to fit your specific domain can really significantly boost your performance. Um, which, speaking of that, that's what this paper is, and creating um, not just regular embeddings for general language, but embeddings for clinical language, or financial language, or health insurance, well, language, like um, further downstreaming what BERT can do with different domains, whether it's clinical data or whatever. Sometimes BERT can be too broad. And it's a great general, language model, but maybe you need a more specific language model, something more specific towards your domain. Um, and, th- you could have different um, models like Albert, um, which stands for a light BERT, and something that's more efficient due to less parameters or reduced parameters significantly, or distill BERT. Maybe something that is either the same level of accuracy, um, or a little bit less, but it's faster. And maybe that's something that you want to have. Um, and so, just a couple of takeaways is uh, a lot of these strategies can be very beneficial, and it just takes reviewing the literature that's out there and examining like what other authors have done, and really just exposing just vulnerabilities to provide insight in how you can expand and develop and create a corpus to fit all possible examples, as representing your population, right? So in conclusion, I wanted to show like kind of what a literature review looks like, and just like the thoughts that you should be asking yourself, and what things that you should be like discovering like other people do. And you know time is another great thing. Like I wanted to find literature between 2019 and 2020 so that it has more relevant aspects to show like the power of these models, and how to improve it. um and of course, like everybody's tasks look differently, whether it's the size of the data, the type of the data, um, the length of the data, what the data is capturing, the domain. However, reviewing several tasks, reviewing what a lot of authors have done, can improve your research, even slightly. Um, and I think, there's a lot of areas of future research and with the aspect of BERT, for specific domains. And I think that that's a great direction to go with improving results. So, different aspects of this literature, it's like, BERT can be fine tuned. Um, BERT has different vulnerabilities. Pre-training towards a specific domain is probably best. And, being a data scientist is hard, but it's very rewarding. And you see so many unique uses for these powerful tools. And you just have to do your due diligence and do your own research and make sure that you're eliminating as much biases as possible. So I'm going to drop the um, GitHub link in the description. If you have any questions, let me know. I hope that this was a good kind of overview, just like a brain dump of what a literature review is, kind of the thoughts that you could be having and asking and seeking out what other people do and kind of how to like write about it. So thank you so much.